Thank you very much, sir. And it was great to see Dr. Jay Kumar. And as he said, I can certainly vouch that when he took office as a defense secretary, earlier than that, seeing the defense secretary office was a very rare thing. But during his tenure, just to send him a message and an email, getting appointment with him and being able to talk with him and take his guidance was something new that the private industry was able to see. Perfect. Okay, great. So thank you very much for the invite. This is our Advanced Manufacturing Technology Center in Lucknow. Before we start on my presentation about, I think I'll touch upon certain things about the general theme that's happening in the country. As Dr. Ajay said, there's a massive impetus that has started in the last few years related to indigenous manufacturing and Atmanirbharta. And as you can see with all these figures, I'm not going to get into those details. Those details, but you can see the trend. The trend is that it is increasing. All the defense production values, the imports are reducing to a certain extent, and the exports are increasing. There's huge investments that are coming up, especially even in all both the corridors, UP Defense Corridor as well as Tamil Nadu in the recent past. There's also an added thing related to the entire aerospace ecosystem, with everybody knowing what Air India made a huge order, but this data is even before that, so that's not covered. But there is this merging of, when we say at defense and aerospace, we sometimes leave out the civil aviation part, which is also a very, very big portion of this. So when we see this going forward, there is a massive increase in spend in excess of $6 trillion over the next few years in the aerospace sector alone. For India, there is a massive opportunity, as these are the primary drivers. There is an increase in defense spending, not just in India, massive increase, but all around the world. Indigenization, Atmanirbharta, self-reliance has become a very important aspect of the government, the Ministry of Defense, especially in the leadership of Dr. Ajay Kumar. And what has recently happened in the last 2, 3, 4 years since COVID, that supply chains have totally been disrupted, starting from what happened with China disruption, but more recently with the Russia-Ukraine war. What that has created are massive opportunities and gaps, which as a country, we are sitting at the right position to take on. However, all these growths, all these opportunities are going to be primarily technology driven. When we say technology and we talk about self-reliance, we also need to understand that self-reliance is not permanent. It's still a temporary feat. So when we say that, okay, we have self-reliance in auto currently, probably in the future we won't, when in the era of EVs, because majority of everything that is being done is being imported, right, from motors to batteries. So it's important to have a filter, have a glass of looking at it from probably a different perspective of trying to create parity. Self-reliance through parity. What does that mean? So when we want India has been after getting a UN Security Council, a seat on that position, because we want to be treated at par. We want to be treated equally. And at the same thing, we should have the same principle or the same goal as a country to be treated at par in technology with the rest of the world. Whether it is in terms of quality, workmanship, skill, know-how, knowledge, all those aspects related to manufacturing technology, we should be trying to aim for that parity. From now, here I will try to define or try to explain what do we mean by technology in our context, especially in the aerospace and defense, and probably more in the context of what we do as well. So, the technology, we look at it as a pyramid. Of course, we need to build platforms and equipment. Of course, we need to build systems and products. And we need that. But we can't start building a penthouse or the top floor of a building before we have the foundations already in place. The foundational technologies are for manufacturing of components and what Dr. Singh addressed in his question related to materials. With the absence of these two technologies, you cannot have a sustainable level of production. What Dr. Ajay also said, that even with DPSUs probably producing 70,000-80,000 crores worth of products, 40,000-50,000 crores were still being imported because they were dependent on the components and the material from the external countries. And still the case. So, technology has these four portions. There's a design and engineering technology which assists in is required for platform and equipment manufacturing. There's an integration, testing and assembly related technology which is related to systems and products. There are certain core manufacturing technologies which are related to component manufacturing, and there are certain critical material processing technologies which are related to materials manufacturing, process materials. Same thing, same theme if you go to air defense, same platforms, aircraft, helicopters, subsystems, airframe propulsion, aero engine parts for components, and then titanium materials and cobalt materials. So same here you will see. Getting a little bit more into detail, same thing. Aircraft being the platform, airframe being a subsystem with the components being bodies, wings, tails, noses, even fans, compressor, turbines, but materials used inside that. We need to be aware where we are not self-reliant. We are not self-reliant in this area, even though we have the aircraft LCA Mark 1 ready today. We don't have all this. We don't have all this. We don't have the component level capability or the material level capability. Even today, even the aero engines, the engines that go on the Mark 1 are imported. The components that go into making of the engine, no capability. So let's looking at into the same pictorial thing. So all the entire aircraft, what product and what materials? Dr. Singh talked about rare earths. Same. You can look at these studies. The entire engine, if you look at it, all the blue stuff is aero engine is titanium. All the red stuff is all nickel-based superalloys. If you look at strategic systems, same kind of a tiering in a pyramid for technology. Same breakup in different parts of the type of missiles. I'll just walk through these. Same is the situation with land defense system, tanks, artillery guns, naval defense systems, submarines, frigates, ships. Everything that you'll notice that each of it has components, subsystems, and within the subsystems you have components, and components within components you require certain materials. We need to know where our reliance is, where do we depend on the rest of the world. Now, coming back to our company, so that I took as for setting the theme as to what context I'm going to talk about in reference to our company. So our company is basically into manufacturing of components and materials related to metal. And there's two portions. There's PTC Industries and there are alloy technologies. PTC Industries is into manufacturing defense-related equipment, but alloy technologies primarily focus on all aerospace-related components and materials. So we have an aerospace castings group and an aerospace materials group. There's a bunch of technology that we have created over the last 20 years. We have received various awards, from National Award for R&D. We received CII's Most Innovative Company of the Year award. We received Time Magazine's Most Innovative Company of the Year award. So, but I will not get into all these technologies, from die cast to control microstructure, forge cast, replicast. All these technologies are indigenously developed, and we are exporting. So Dr. Sanjit in his address also talked about these different TRL levels. We also follow the same process of MRL, manufacturing readiness levels. We have our own definition of what does that each level stand for, and that's how we keep on pumping out all these technologies into our in our company. At a given point of time today, we have probably 6 to 7 technologies which are at MRL 8 to MRL 10, and then we have another 7 or 8 technology which are still before MRL 7. So at any given point in time, we are working at around 15 to 20 technologies. The objective for that is to keep on not be complacent and always have the future in our sight. Now coming to some of our context related to our company. So the aerospace castings group that we called is mainly focused towards exotic and critical and supercritical material castings for extremely critical applications, like right from aero engines to aerospace and all these civil as well as military aircraft. Probably, okay. This one did not work. Let me see if it works. Should work. Okay. So we have our own titanium casting manufacturing. So we are the only ones in India manufacturing titanium casting, exporting as well. We have our own in-house lab, nationally accredited lab. We have other scheme that Dr. Ajay Kumar mentioned about, related to creation of a defense technology lab. So that's what also we are vying for. But this is the first time a technology related to titanium casting was brought to the country. This was a significant feat for any private industry to do without any orders. All this setup of another 200-300 crores was done based on building a capability in the country. The objective being parity, self-reliance. A lot of advanced manufacturing practices, right from modeling, simulation, 3D printing capabilities, all the way to simulation capabilities. Everything is available in-house with our people. Lot of training has gone into this. Lots of years of training has gone into this, of making people ready for this. Again, this one is not working, so yeah, it's working now. Lot of use of Industry 4.0, advanced manufacturing practices, robotics, automation. This is the world's largest robot. Only 4 of these exist. But trying to look at different areas of manufacturing and innovate and figure out what's the best way to do it, so that we can meet the requirement of the consistency in the quality that is required for aerospace, at the same time do things differently than the rest of the world and be at par with the rest of the world. Again, another very important capability that now is there is a hot isostatic pressing capability. This is the only hot isostatic press that exists east of Germany and west of Japan, barring Russia and China. And it's among the 5 largest hot isostatic presses. Hot isostatic presses is basically for healing of cast parts, but also for diffusion bonding, many applications. But it's a, we got it from US, took us 3 to 5 years to get the export license from the US to get this technology and this capability within the country. Again, the only one in the country and in this entire region. Another capability that has just been brought in is controlled microstructure castings for single crystal blades, directionally solidified blades, equiax blades for all aero engine and even other gas engine requirements. Again, a capability, at least in the private sector, wasn't there or isn't there. Huge investments in machining, 5-axis machining for large 5-axis machining for large aero engine parts, turbine parts, all that capability and equipment is already there. Besides this, now what is getting created is a big expansion of all these capabilities. So we add, this is a just a additional 16,000 square meters of space is getting created for making this expansion of the castings group in the defense corridor in Lucknow, right next to the Brahmos plant, where we have got 50 acres of land, and a lot of new capabilities further being added over there. This is our 50 acres of land, layout and all that stuff. New titanium casting, vacuum arc remelter is being added with a melting capacity of 400 kgs, very large, probably amongst the top 3 largest ones in the world. One of a very large vacuum induction melting capability is being added for making castings up to 1000 kgs. Again, one of the largest in the world. All this is after 7-8 years of pure R&D and manufacturing and proving out all our capabilities. Vacuum heat treatment capabilities and some additional robotic systems and 3D printing capabilities and all additional hot isostatic presses, radiography, FPI, all the such capabilities. So the products that are being made from the currently being made from the existing capability, all the yellow ones that you see are castings that go on the M777 ultra lightweight howitzer, for which was bought by India from BAE Systems. We have been working with them for 5 years. Now we have almost indigenized all the castings in titanium castings. ULH is ultra lightweight because it's entirely made out of titanium. So this whole thing is titanium. So this is a gun split in half. So you can see, but it's all the yellow ones are the ones which we have already indigenized. And many more are going on, and then the entire assembly of the gun will also happen here. And again, so the entire titanium casting that you can see on the top. This is the new 2000 kilonewton engine that will power the ISRO's NGLV, and this portion that you see is this pump in titanium that has been produced by us, that's going on the NGLV. Recently, for the GTRE's Kaveri dry engine, this oil tank assembly, that's again titanium, that's all castings and everything machining was done by us. Now the reason to show all this is because all this was being imported till now. Turbine casings for various engine programs, for HAL and other GTRE programs, for both in super alloys and titanium. Now we have got the first order for manufacturing titanium parts, super alloy parts for civil aircrafts for a European company, Safran. So this is the first order that received for producing parts for aero engines that goes the LEAP engines kind. These are landing gear systems. So landing systems, again, landing system for European manufacturer which we are developing. This again a titanium part. These are again fighter aircraft parts for Rafale. All titanium parts which has been developed by us. And many more are on the way. Now, on top of that, we are again now adding an entirely materials group which is being set up for manufacturing all critical and strategic materials for the country. That's another very big gap in the country. And so for manufacturing titanium superalloy, well, as mentioned, probably Mitani also has some capacity to do that, but not at a very large level. So this is the plant that is being built. It will be hopefully ready in the next 4 to 5 months. It's, as we speak, it's under construction. Again, in the same defense corridor in Lucknow, right next to the BrahMos plant. Some layout. Now, titanium manufacturing, alloy manufacturing, titanium material manufacturing basically has 3 types of melting. One is your vacuum arc remelting, the other is electron beam melting, and the third is plasma arc melting. But in the electron beam and plasma arc, there's also a cold hearth remelting as well. What we are doing is bringing all those 4 technologies at the same time to the country. Not 1, not 2, all 4. So the video is not very clear here because of the lights, but so here you can see the cold hearth refining, remelting happening. This is a ingot coming out from a VAR. So there's a huge VAR that is being added, which will be able to produce ingots up to 12 tons single piece, 12,000 kg single piece, up to a diameter, almost a 1 meter diameter. Again, it will be commissioned by first quarter of next year. Again, state-of-the-art equipment from German manufacturers. This is a very interesting equipment that's coming. It's electron beam cold hearth remelting capability. This will be one of the world's largest single site remelting capability for titanium. So how is this different than the previous VR? In the VR, we can only melt titanium sponge or whatever is created from virgin material or from titanium ore or rutile. So rutile is converted to sponge, and then from sponge we can melt it to make titanium ingots, which is usable to make other wrought products and forgings, whatever you want. So it keeps on taking in all the new fresh material every year. In aerospace especially, the buy to fly ratio is generally between 100 to 10. So almost 90% of whatever is taken out is wasted. Titanium, being such a highly oxidizable material, it's extremely difficult for it to be taking that scrap and remelted like you do it in steel. So you take all the scrap and you remelt it. You don't go all the time for a blast furnace and use it from ore. But that's very difficult to do in titanium. There are very, very few places in the world, actually, in the free world, there are only 2 places, France and US, who have this capability to take scrap, to take waste titanium, remelt it, and convert it back to aero-grade titanium. As we speak, sir, the MOD and many other places, they are sitting on tons, hundreds and tons of titanium waste over the years. So this capability is coming for the country, and this will be the world's largest single site melting capability for 5,000 tons per year capability to make them into ingots, slabs, all that stuff. So a very important movement there. A small plasma arc remelting, cold heart remelting capability for making exotic titanium alloys, titanium aluminide. If you want to make a small batch of titanium aluminide, you can make it with this. So an extremely precise remelting capability for titanium. Vacuuming induction melting. So when I mentioned about single crystal blades being made here, the material still would have to be imported. So by doing this, buying this equipment and the technology related to it, we are also bringing the technology to manufacture the material that will be required for the single crystal blades and DS plates within the country. So the entire supply chain is covered. So what that creates is a closed system where we can make our own parts, create the castings or whatever products, machine it, get the waste out, remelt it into the cold hard or VIM, and then again use it. So create a closed system. Also at the same time, because of that reason, there's a very environmentally sustainable thing to do, important thing to do, because every ton of titanium that's produced using EBCHR or cold hearth remelting saves approximately 26 tons of carbon emission. So on a 5,000 ton capacity, that means over 130,000 tons of carbon emissions will be saved every year. So what I was trying to say was that all these capabilities are core manufacturing technologies. The difference between those technology pyramids that we saw in the beginning, the top two tiers or the top two portions are related to systems, platforms, products, equipment. They are platform dependent or platform specific technologies. What we also need is cross-platform applications related to core manufacturing capabilities which are able to service and feed those equipment manufacturers, product manufacturers, system manufacturers within the country. We can't just import aero engine technology here. What will we get? We'll get the design capability. We'll probably test some testing capability. But all the components that go into the aero engines will still be imported. All the materials that go into the aero engines will still be imported, and that will be a shame, because that will not mean self-reliance. We'll still be dependent. So again, a lot of successes in the past. We got signed for Dassault for the Rafales and Safran for the LEAP engines. Got the Raksha Mantri Excellence Award. Sir was there at that time. And we have done a deal with BE Systems for creating the whole castings as well as the M777 and structures, all that within the country. All this is happening because of the core manufacturing capability that has been set up. There are hardly very few countries and companies in the world who have such kind of capability, and it's important for us to identify so our domain is in the metal, but there are similar things that needs to happen in electronics and composites and textiles and other streams which feed into this. So thank you.
There's a question.
Yes.
Thank you very much for articulating the needs so eloquently. Really. One thing that comes to my mind is this titanium. You are whatever you have put up in the secondary facility, and we have bulk materials that can probably go into our supply chain for a long time. There is something that is being done. You will be very well aware at KMM with the help of defense and titanium sponge production. That will not probably suffice the needs that we have. We require much larger facility for titanium sponge production as well. And KMML itself is facing a lot of problems, a lot of issues with the equipment that we have. So the question was that, like, I mean, how much of dependence we will have in this Ti-6-4? Like, I mean, import of that. I mean, with this secondary facility, a lot of things can be done, but we will still be requiring a lot of Ti-6-4 for our requirement, which comes like when the sponge titanium being imported from Russia or some other source.
Okay. Yes, sir. So, no, so for what you said is absolutely right. So, just to give you a base for that, pre-COVID, approximately 280,000 to 300,000 tons of titanium were being produced in the world. Out of that, about 120 to 140,000 tons was produced or is produced in Russia, and around 50 to 60,000 tons is produced in China. So that leaves another 120,000 that comes from the rest of the Western world. Of course, Mithani producer, but it's almost insignificant in the total context. Sponge primarily comes from Eastern European country, Kazakhstan, Kyrgyzstan, Ukraine, Japan, and China, and some Russia. So there are two things. First of all, currently, because of this conflict that has gotten created, there is a huge gap in the market where the Western nations need titanium, but it's primarily Russian or Chinese. So first is that. Now, second part of it is what you said about dependence on sponge. Yes, KMML is doing, but as you said, the capacity is not big, and I think that's where the government needs to focus on trying to create and expand that capability within the country, because we don't have any lack of the ore, rutile or ignimite or whatever. So both are a reasonable capacity or quantity available within the country. It's just the conversion from that to sponge. So that, as in an investment that the government should certainly look for at least promoting. But what I said is, keeping that in mind, because there will be a lot of dependence on sponge, that is why the decision has been taken. We took the decision of getting an EPCHR with that. So out of the 6,500 tons of capacity that we are creating per year for titanium production, 5,000 tons is coming from being able to remelt waste titanium, which is in ample supply. So not to further keep on, doing that. So yes, both has to be addressed, but I think for now,
yeah. Because it is just kind of akin to, if I compare with steel technology, this is a secondary processing actually.
Yeah.
Carbon footprint.
So we don't take up that much sponge. Thank you. Thank you. Yeah.
Where is it located in Lucknow?
So it's closer to you than it is to Lucknow. So it's on the Lucknow Kanpur Expressway. If you go to Lucknow, Ramada, you see Ramada. So it's just, if you're going from Kanpur, just one turn before that on the left.
And what's the reason to choosing to be setting up a manufacturing center at Lucknow?
Many reasons. One is, of course, belong to Lucknow. So, and the other thing is also that I think most of the manufacturing has shifted to west and to south of India, and I think it's important to bring certain manufacturing in this area as well, and that is why the government's measure to set up a defense corridor in the north itself.
I can actually add to what he just said, that the reason why in Lucknow, because I have heard him speak in many forums, and because we have this MOU with the UP Defence Corridor, and we are also trying to work with the UP Defence Corridor team to create and strengthen this defence and aerospace ecosystem. And he through his company, is one of the big promoters who are trying to create this ecosystem. So that certainly I can say that.
Thank you. Thank you. Thank you.
I had a quick question, maybe as a comment.
Sure.
Actually, it is very hard to nice what you have created, and good to see that you thought out what are the two that's components and materials. So that was very nice. But another thing I've noticed is that we still have to import a lot of the equipment. I know it's the next stage. This itself, if it is done, it will give a boost, and maybe it's a cyclic thing. But what part of it is because the big equipments that you have purchased, there also the components and other things will be needed. So how dependent are we on that?
So I think that's a reasonable question to ask, but at the same time, I think we have to approach it at a step-by-step manner. Yeah, I think that's one of the issues that Dr. Ajay also said that in his speech, that try to do something first. Even if it is not 100%, try to make the first step. You get there and then you take the second step. So yes, there will be the equipment. So I think for the what you mean, the spares and everything. Yes. So the spares generally, when we bought from the same equipment manufacturer, we bought the equipment for titanium, initial one, about 7-8 years back. And from then the spares and parts, whatever earlier was 100%, now it's come down to 30%. So 70% we have figured out to source from here. So that will happen over a period of time. As we said, reverse engineering, all that stuff starts happening. Thank you.